We've talked a lot about quadratic equations, but let's talk about how do we graph a quadratic equation. And specifically, how do we graph a quadratic equation when it is in standard form, which is ax squared plus bx plus c. Just a reminder, it's kind of important to know these key parts of a quadratic because these are the ones that are going to help us graph it. And also a lot of times when we're using quadratics in real life, these are the points that are the most important. So whether the quadratic, the parabola is opening down or whether it's opening up, we pretty much always want to know the vertex. Where is that vertex, that maximum or that minimum point? Because all of the points are going to be symmetrical around that. The axis of symmetry goes vertically through the vertex. We want to know, a lot of times we want to know what that x-intercept is or where it crosses the x-axis. And we want to know the y-intercept. And we want to know the x-intercepts, where that crosses the x-axis, also called the zeros, also called the roots. So these are kind of the points that we want to know how to find. So let's talk about quickly how to find them. How do we find the vertex? When it's in standard form, super easy. The x-coordinate is found at -b over 2a. So find your b and find your a from standard form, and that gives you your x-coordinate. When you find your x-coordinate, you can plug it back into your equation to give you the y-coordinate. Super easy. Is your vertex going to be a minimum or a maximum value? Take a look at the coefficient of your quadratic term. So when we have ax squared plus bx plus c, take a look at that a term. If it's a positive, then the parabola is opening up. It's going to look like that, and your vertex will be down like that. If the coefficient, if that a term is negative, then your parabola is opening down. It's going to look like that, and the vertex is going to be the maximum or the tallest possible point. How do you find the axis of symmetry? Well, it's running vertically through the vertex, so whatever your x value is of your vertex, that's going to be your line. So that's pretty easy. So just find your vertex, and then your x is going to be its x equals whatever the x value is of your vertex. All of the x values are equidistant, or they're the same distance away from that line of symmetry, and they're going to have the same y values, which makes it really easy to find values in an xy table. Roots or solutions, or we could also call these the x-intercepts. Where do these cross the x-axis? How do we find these? Well, you're going to factor your equation. And it might be either basic factoring, woohoo, or if it doesn't factor nicely, you might have to complete the square, or my fallback is the quadratic formula. You're going to use those to find your x values, where your parabola crosses the x-axis. We use our roots a lot when we're dealing with real-life situations. The y-intercept, look at the constant term in your standard form. So an ax squared plus bx plus c. C is your constant term. This is your y-intercept. This is where your parabola crosses the y-axis. Why does that happen? Well, when it crosses the x-axis, your y-coordinate is 0. And when you have 0 here, that makes this term 0, and this term 0, which means this is your only term that has a value. When you are graphing your parabola, you're going to want a few more points. So you're going to want to make an XY chart. You're going to pick a couple nice X points based off of your vertex, because you want to find them on either side of your vertex, on either side of your line of symmetry, because when you do that, the Y values are going to be the same, nice and easy. So you're going to pick out a couple X values that make sense based off of your vertex, find their Y values, you graph them, and connect your dots. It's going to be a curve. And then this we'll talk about later, but keep this picture for later because we'll talk about that later with AOPS. Let's go ahead and do an example where we actually graph a parabola. Let's go over how are we going to graph this parabola. This specific parabola is y equals 2x squared minus 4x minus 6. We want to, and notice it is in standard form, we want to graph this. So first things first, let's break it down into some of its key components. Write down what A, B, and C are. Okay, well, A is 2, B is negative 4. Remember, the sign goes with the number. And C is negative 6. All right, does the parabola open up or does it open down? To do that, we're going to take a look at our A coefficient. It is positive, so our parabola is going to be opening up. It's going to look like that. Our next thing that we want to do is we want to find the vertex. And just remember, our x-coordinate of our vertex occurs at negative b over 2a. So I'm going to go ahead and find my x-coordinate first. Negative b, the opposite of negative 4, is positive 4, over 2 times 2. 4 over 4 is 1. So my x-coordinate is 1. Now I'm going to plug 1 back into my original equation to find my y-coordinate. So y equals 2 times 1 squared minus 4 times 1 minus 6. 2 times 1 squared is 2, minus 4 minus 6. 2 minus 4 is negative 2, minus 6 is negative 8. So my x-coordinate is 1, my y-coordinate is negative 8. 1. My vertex is at 1, negative 8. That is a great point to know. Find the axis of symmetry, and if I were to just kind of do a really rough drawing of this, 1, negative 8 would be about down here. My parabola is going to be looking, I don't know, something like this, very rough. My axis of symmetry is going right through my vertex. So, and that is the line x equals 1. So this line right here is the line x equals 1. It is a vertical line. That is the axis of symmetry. Is my vertex a maximum or a minimum value? Since it is opening up, it is a minimum value. There's no other smaller point on the parabola below that value. All right, let's do the next part. We found the vertex, the axis of symmetry. Now let's go ahead and find the roots where it crosses the x-axis. So hint, factor the equation. Well, I'm going to factor, I know it's over here. I'm going to rewrite it. 2x squared minus 4x minus 6. And I'm going to go ahead and try to factor this out using basic factoring. My intuition tells me it's going to factor out nicely. First thing I'm going to do is I'm going to factor out a 2 because that's going to make factoring easier. And I'm seeing that I can factor, I'm looking for factors of negative 3 that are going to combine to get a negative 2. That's going to be a negative 3 and a positive 1. So I factored it. Now when I go ahead and I set each of these equal to 0, I'm going to get x equals 3 and x equals negative 1, which means my roots are at 3, 0 and negative 1, 0. That is where it's going to cross the x-axis. My next one, I'm going to find the y-intercept. And my hint is to look at the value of c. My value of c is negative 6. That's my y-intercept. So it's going to cross the axis at 0, negative 6. And that's because when I plug in 0 into my equation, I get 2 times 0 is 0. I get negative 4 times 0 is 0. And then I get negative 6. So my value is negative 6. So the y-intercept, we don't always have to find it, but it's a really easy point to find. It's just whatever your c value is. All right, next step. We found our vertex, we found our zeros, we found our y-intercept. Let's go ahead and find a couple of other points that we can graph, that we can kind of connect our lines. So I'm going to start with my vertex. I'm going to use that as my starting off point, which is why we found that first. My vertex is 1, -8. So notice 1 is my x value. So all of my points, if I were to draw a really rough estimate of it, 1, -8 would be down here. Okay, it's going to look, I don't know, something like this. All of my points are going to be equidistant. So if, let's see, if this is 1, if I'm going to pick 2 and 0, I would pick those because they're both 1 away from the x coordinate. They're both 1 away from that axis of symmetry. So therefore, I know that the point x equals 2 and x equals 0 are both going to have the same y value, which is pretty nice. So if I just figure out one of these values, I've figured out the y value for both of them. And I'll probably do the same thing. I'll do like 3 and -1, which I know are the roots because I just figured that out. And maybe, I don't know, let's go ahead and do like 5, just see what happens. All right, so I'm going to plug. So that's how I figured out what x values to figure out. If you just start doing random x values, depending on the equation, you could get something really funky. So that's why it's important, well, I think it's important to find your vertex and then find some values on either side of your vertex. All right, so we're going to go ahead and figure out what these are. I'm going to plug 2 back into my equation and see what our y values are. All right, now I have a bunch of points here. Notice that 524 is going to be a little interesting. We might not actually be able to graph that one. All right, so let's go over here and let's go ahead and graph our parabola. And then, because the point is we want to graph enough points that we can kind of roughly shape in our curve. So let's start with the vertex, which is at 1, -8. So here's 1, -8. And notice that the kind of the parameters of this vertex, of this graph, were already kind of set for us so that we could graph it nicely. And let's go ahead and graph some other points. 2, -6. And 0, -6. Notice these both have the same y value because they are equidistant from our line of symmetry. 3, 0, -1, 0. And notice 524 is going to be like way up here. I'm not even going to be able to graph that one. So I'm just going to try to roughly connect these in a somewhat U shape. And I'm going to put arrows. It kind of looks like a V, but you know, we do our best. And put arrows on either end of there to show that this this curve is continuing up and up and up and up and up and up forever. And that is how we graph a parabola using standard form. We find our vertex, we find our roots if we can, we find, and our roots don't always turn out to be nice integers. In this case they did. So we find our vertex, we find our roots, we find our y-intercept if that's helpful. We find, based off of our vertex, we find a couple of nice points, and then we just kind of graph it and make the best possible graph that we can. Pretty easy.